Hi guys, I got a little lighting project for you today. We got some Chinese projector lights for vehicles, and I'm going to modify them so they work on the machinery here. I got one of them done, sort of got pieces of it recorded, and then I got the other one today. So I got a little more recorded for that too. So I hope you enjoy it, and here we go. Okay, so originally this light came with this big goofy looking projector lens on the front of it, and that was not really suitable for machinery applications, because what this lens does is make this into a projector with a 30-degree cone angle. And so they're designed with this lens to be, shooting way out there, 20, 30 feet. When you put this up, within a foot of like what you want to look at, like you would on a mill, it was just like a very tiny, bright spot in the center, and then a lighter kind of a ring around it, defocused spot. So it's no good. So what I did is I made some plexiglass lenses, and let me take this apart and show you. Hang on. Alright, so what I did was I trepanned out this lens out of plexi, which just keeps the chips out of it, really. What you're looking at out of this now is like a 60-degree cone angle out of the LED. And here's what's inside of this thing. And you can see I had to do some stuff to it, because one of the things this comes with is like a strobing feature, which I don't know, man. I wouldn't even, if this was on a vehicle, I wouldn't even use it. But they have it. But anyway, there's a chip down here that does that, and as you can see, that is now gone. Here's the LED in the center, and the way this board is aluminum, so it's a really good conductor of heat, and this LED is mounted right onto it. And then all you're seeing out of this thing is just the raw LED output. It just shines right out there, no lenses or nothing. And that seems to be perfect for the machinery. If you want, you can focus it down even more. If you can buy these cheap 50mm, they call them close-up lenses for these camcorders. They cost nothing on Amazon, a couple bucks a piece. You can put one in here and it'll focus it down a little more, but I kind of like it the way it is, so I'm going to leave it that way. But anyways, yeah, this now is a pretty good machine light, and like I said, it's 10 watts, and the old double boost was 3, and this is what they call that xenon white. It's almost blue, which I don't know if I'm really happy with that yet. I may have to change this a little bit, but the double boost is kind of yellow compared to this, which I never really liked. So anyways, yep, that's how you make a cheap Chinese LED light that's bound to catch on fire into something that is actually useful. Here we go. Alright, we'll get that one out of there. Alright. Alright, so this is what you get. And I think, I don't know if you can count on the airflow to keep this thing cool enough. I mean, even maybe if you're going a couple thousand miles an hour or something, but it gets pretty darn hot. And I think that's why they put this cage around here, is to keep you from getting burned. But that doesn't solve the real problem. So we're going to solve the real problem by making another heatsink out of this thing, on this thing, and I think this one will go on my lathe. Alright, so they RTV these things together. Okay, so this is plastic and it's pretty useless, so we'll get rid of that. This is the heatsink surface here. We got to clean all this crap off of here, and if I can get this unscrewed, there it goes. Okay, this is this lens we don't need, and there's the guts of it. So let me hook this thing up as it comes and show you what kind of spot it makes. Hang on. Alright, so this is what you get. I'm holding this probably a foot away from the mat here. And you know, I don't know, I don't like that. It's too focused. And let me tell you, this shell right here is already getting hot. I don't think I'll be able to hold on to it for too much longer. But if you take this lens out of here and just use the raw spotlight, now I'm holding this about a foot above. You know, you can see it's a much brighter, a much broader spot, which illuminates everything much better in terms of machinery use. So I got another lens. We'll screw that in. I'm gonna make I don't know, I might mount this up to a gooseneck or something with a mag base. I haven't decided yet, but we'll give it the treatment and keep it from melting down. We'll put a heatsink on the back of it and clean it up. Oh, the other thing is this back plate is so warped. I had to put this in the lathe and flat and, you know, face it off so that it would make good contact with my heatsink, because I don't know what they're doing to make this thing. Probably stamping it or something. But there you go. Second lens, second light. This one will go on the lathe, I think. Okay, so now we're going to get into the nitty-gritty of modifying one of these lights. What you have to do here is, if you get one of these things and it's got that stupid strobe mode in it, is to remove a chip. And it's right at the top, right where that black square is. Okay, and then that will enable this LED driver in full blast on mode. So here's the board that sits in the bottom of this shell right here, and it's basically a plate of aluminum with the printed circuit stuff on the top, and this LED is bonded to that plate. You can see there's some heatsink paste here. I've already wiped the heatsink paste off of this part. So now what we're going to do is we're going to chuck this up in the lathe, and I'm going to just face this off back here and attempt to get it as flat as possible, so that when we make the heatsink,
it'll fit on there. You'll make good thermal contact. And what happens here is they had sheet metal screws screwed in here. We're gonna drill these out to 440, and then when we put the heatsink on the back, we're gonna screw through the board here, through this back shell, and into the threaded heatsink, which is gonna then sandwich this part between the heatsink and the board with a lot of, hopefully, force, and then that will allow the heat, the waste heat from this LED to be radiated into air through that heatsink. So first thing I'm going to do is chuck this thing up and face this off in the back here.
Alright, I get this thing chucked up just on the threads here, because it's the only part of this thing that actually runs true. And we're just going to face off the back here till we clean it up. Take as little off as possible. Yeah, you can see how flat they made this thing. Okay. Alright, I'm just going to turn it around to the other side, make sure we get a nice thermal surface. Okay, so you can see I've turned the inside here. Now the both surfaces are parallel to each other. And give you a shot of the tool bit, how we had it. Okay, so now we got to drill two clearance holes for 440 in here, and then we'll be done with this piece. Okay. Let's see what we ended up with here. 1 inch. Alright. So our fins are going to be 3/4 of an inch deep, because that's the limit of my end mill. And we'll have a little base plate here for the 440 screws to go into. So let me pull this out a little. We got to turn down the end of this just a tiny bit. It's got to be 1.855, and this is 2-inch stock. Yeah, 72 thou we got to pull off of this. And we gotta pull it, we gotta do 220. Set up this. Oh, we might as well do it on this side. Okay. There's 220. Let's feed this by hand. Okay, that's definitely fitting on there good. Okay. Alright, cut the fins. Let me get that out the file. Okay, get it set up in the milling machine. Okay, so we got to center this baby up underneath, right? So we get our trusty little mandrel out. Put it in this way. Where did I put the chuck key? There it is. All right. This is what you do with broken end mills. You never throw this stuff away. That's a little better. Okay. Yeah, it looks real good. Good enough for what we got to do. Okay, so we will zero the DRO and get rid of that. We'll put our piece in. Okay. We have a better one. Okay. You got to put an end mill in this thing. Okay. Where's my doohickey? Okay, so the way this works is I've done the numbers here, and we're going to put one groove 1/4 inch wide right down the center. I'm going to step over 350, put another groove in, and step over 700, put the third one in. We'll do that on both sides of center. We're going to go down 3/4 of an inch because that's a good number. Let's get going here. And we're going to run this thing at 1,000. Now let's make it 1,200. And we're going to turn on our Z-axis so we know how deep we're going. I'm going to zero it. Okay. Hate it when that happens. The vise fell in the aluminum scrap bucket. Let's try that again. Come down 50 thou. And engage. I gotta get the compressed air going here. Okay. so you get the idea. I'm just gonna cut down here, and you know, it's kind of boring, so I'm not gonna make you watch it. Be back when we're done. Last pass. Alright, now we got a lot of deburring to do. Okay, I think she's pretty much done. Got to make a little yoke for it. But when I first got this light, there was no heatsink on the back. It was just a plastic shell, and this black part and the screw-on bezel were the only heatsink for this 10-watt LED. And this part right here, after about a half an hour, got up to about 170 degrees Fahrenheit, which is way too hot to touch. This thing's been running for about an hour now, and it's pretty happy. And you can't dissipate 10 watts into a little round shell like this. It gets stupid hot. Then the junction, you know, I mean, obviously if this is at 170 Fahrenheit, the junction inside of there is probably way over 200 Fahrenheit, which is crazy. It's never going to last. It's going to fail, you know, you're going to have all sorts of problems. So I put this heatsink on the back, and I didn't put any thermal grease on here at first. And this was running at 110 F, and this was running at like maybe 80 F. So I took it apart again, I scraped all that thermal grease out of there that came from China, and I put some good stuff in. So the way it works is there's a board in here, there's a layer of thermal grease, then there's the back shell of this black part, then there's another layer of thermal grease, and then this. And the screws that go through the board that sandwich this to the black part. So now heatsink's running at 108 Fahrenheit, and I thought I saw, yeah, 109 on the black part. So there's good thermal conductivity between the heatsink and the diode. So this will live happily. And what I'm going to do is I'm going to make a yoke that screws on here so I can pivot it and twist it, and I'm going to mount it to my mill. Alright, so after a little consideration, I think I have finally settled on the appropriate mechanism for holding this light. And we got tiltability and all kinds of good stuff going on here. And it still goes up in the hole. So yeah, we're looking pretty good here. I think I'm going to leave this alone and move on to the lathe. Okay, Mr. Lathe Light is complete, and I think that's pretty damn cool. So I got it on a mag base, which means I can put it anywhere I want. And right now I got it riding on the cross slide here. Nice. Okay. So just for comparison's sake, I've got the double boost light here. Okay, now you can see the color difference. How's that? So 3 watts on the left, 10 watts on the right. Alright. So we'll try these out for a while, see how they work out. And if we need to change anything, we will. Okay, so there you have it. Another little Wrong Fu mod for the mini mill fans out there. So thanks for watching, and well, I'll tell you, I'm pretty amazed. We're up over 300 subscribers. I think it's like 310 or something like that the last time I looked. So man, I appreciate it. Thanks for the support, and we'll keep trying to bring you interesting stuff to see. So thanks again.